Hello and welcome to AI for Developers. I'm Chaitanya talking bot. Today's lesson is titled Building a RAG Application. Your first smart search bot with external data. Imagine you have a super smart friend. That's our AI, a large language model or LLM. This friend knows a lot about general topics because they've read tons of books. But what if you ask them about your specific company's internal documents or asterisk the latest news from yesterday? They'd likely say, I don't know that specific detail. RAG, which stands for Retrieval Augmented Generation, is like giving your smart friend a superpower. The ability to asterisk instantly look up specific, up-to-date information from external sources before answering your question. It's how we build AI that knows your stuff, not just general stuff. Our super smart friend is an LLM. Think of it as a brilliant student who has memorized an entire library up until a certain date. It can write poems, summarize history, or even write code. But here's the catch. Its knowledge is asterisk fixed to when it was last trained. It doesn't know about events that happened last week, or the secret recipe for your grandma's cookies unless it was specifically in its training data. So, asking it about your private documents or today's stock prices is like asking a history professor about quantum physics, not their specialty, and not in their curriculum. This is where RAG steps in. Imagine your smart friend now has a personal, super fast librarian by their side. When you ask a question about something specific, like your company's latest sales report, your friend doesn't just guess. Instead, they first ask the librarian, that's the retrieval part of RAG, to find the exact relevant sections from your company's sales reports. Once the librarian hands over those specific pages, your friend, the generation part, reads them and then crafts a perfect, informed answer based on asterisk that current, specific data. This makes the AI not just smart, but contextually aware and up to date with your information. Before our smart librarian can help, we need to organize your books. This first step, ingestion, is about taking your external data, like PDFs, website content, databases, and preparing it for the AI. First, we asterisk break it down. We chop your big documents into smaller, manageable chunks, like individual paragraphs or sentences. Next, we make it asterisk understandable, embeddings, for the computer to understand these chunks. We convert them into special numerical codes called vector embeddings. Think of these as unique, digital fingerprints for each piece of text. Texts with similar meanings will have fingerprints that are numerically close to each other. Finally, we asterisk store it smartly. Vector database. We then store these fingerprints in a special vector database. This database is super efficient at finding all similar fingerprints very quickly. It's like having an index in a library that instantly tells you where all books on AI are located, even if they're in different sections. Now, when you ask your RAG bot a question, here's what happens. First, your asterisk question to fingerprint. Your question is also converted into a vector embedding, a digital fingerprint. Then, the asterisk librarian's search. The RAG system takes your question's fingerprint and quickly searches the vector database for the most similar data fingerprints from your external documents. It's like the librarian taking your question, understanding its essence, and then pulling out the most relevant paragraphs from your specific books. The output of this step is a few highly relevant pieces of your original data that are likely to contain the answer to your question. This is the retrieval part, getting the right information. With the relevant data chunks in hand, it's time for the generation part. First, the asterisk I gets the context. The RAG system takes your original question and the retrieved relevant data chunks and feeds both to the main AI, RLLM. Then, the *I reads and answers. The LLM now acts like our smart friend who just received specific pages from the librarian. It reads your question. It reads the retrieved context. And then it uses its vast general knowledge combined with the specific new information to formulate a precise, informed, and accurate answer. It doesn't just guess. It cites its sources internally by using the retrieved data. This ensures the answer is grounded in facts from your data. From a developer's perspective, building a RAG bot involves connecting these pieces. You'll need * data loaders, tools to read your documents like PDFs, text files, web pages, a * text splitter, code to break documents into smaller chunks, an * embedding model, an AI model that converts text chunks into vector embeddings, a * vector database, a specialized database like Pinecone, Chroma, FAISS to store and search embeddings, an * LLM, the main AI brain like OpenAI's GPT models or open source models that generates the final answer, and an * orchestration framework. Libraries like LangChain or LlamaIndex help you easily combine all these components into a working RAG application, handling the flow from question to answer. You'll write code to define this pipeline. RAG isn't just a cool trick. It's essential for practical AI applications. It provides * accuracy and freshness * because AI answers are based on * your latest, most relevant data, not just old training data. Eliminating "I don't know" or outdated info. It leads to * reduced hallucinations. By grounding the AI in specific facts, it's less likely to make things up, a common problem called hallucination. RAG offers * transparency * as you can often trace which parts of your documents the AI used to formulate its answer. It's * cost-effective, no need to retrain a massive LLM every time your data changes. Just update your vector database. Plus, it enhances * privacy and security * because your private data stays within your control. Only accessed for specific queries. Not used for general model training. This makes RAG perfect for customer support, internal knowledge bases, legal research, and much more. Thanks for watching. If you found this helpful, make sure to subscribe to our channel and hit the like button.